morning, sir. Good morning to our laboratory assistant, and good morning to our dear friends. First of all, before we begin our presentations, we would like to introduce ourselves first. My name is Dea Anissa Putri, and my partner, Evelyn Angelica from MSP 2019. Now, we will present our project task about analyze Pearson correlations using SPSS application. So in this project task, there is 3 chapters. For chapter 1 is preliminary, chapter 2 is discussion, and chapter 3 is closing. Chapter 1, preliminary. Background. Correlations explains how one or more variables are related to each other. These variables can be input data features which have been used to forecast our target variable. Two features or variables can be positively correlate with each other. It means that when the value of one variable increases, then the value of the other variables also increases. Correlations is a statistical measure that expresses the extent to which two variables are linearly related, or meaning they change together at a constant rate, and it's a common tool for describing simple relationship without making a statement about cause and effect. For finding correlations, some students or some people often use SPSS as their software for finding correlations correctly and easily. So we are from Group 4 make this project task to make people know that SPSS can be used to analyze correlations and give them some steps of how to use it to solve their correlations problem. The formulations of the problem of this project task is first, what is meant by Pearson correlations? Second, how to do Pearson correlation test using SPSS applications? Third, how to calculate correlation manually? Fourth, how are the results of the correlation test in this case study in this paper? The objective of this project task is first, to find out the meaning of Pearson correlations. Second, to find out the ways to do Pearson correlation using SPSS application. Third, to find out how to calculate correlation manually. Fourth, to find out the result of the correlation test in this case study in this paper. The benefits, first, readers will know and understand about Pearson correlations. Second, readers will know and understand about finding Pearson correlation by using SPSS applications. Fourth, readers will be able to calculate Pearson correlation manually. Fourth, readers will be able to conduct a Pearson correlations, the result of the correlation test in this case study in this paper using SPSS application. The next one, chapter 2, will be explained by my partner, Evelyn Angelica.
Okay, thank you, Dea, for the opportunity. I will discuss about the chapter 2 discussions. The first topic is theoretical reviews. First is correlations. A correlation is a statistical test to determine the tendencies or patterns for two or more variables or two sets of data to vary consistently. In the case of only two variables, this means that two variables share common variance, or they covary together. To say that two variables covary has a somewhat complicated mathematical basis, covary means that we can predict a score on one variable with knowledge about the individual scores on another variables. And the correlations has a range from -1, 0 to 0.1. When the correlation is 0, there is no correlations or relationships. When the correlation is more than 0, it is a positive correlations. And then when the correlation is less than 0, it is a negative relationships. The second is Pearson correlations. So Pearson correlations is widely used in statistics to measure the degree of the relationships between linear related variables. For example, in the stock market, if we want to measure how two commodities are related to each other, Pearson correlation is used to measure the degree of relationships between the two commodities. So, if we would like to conduct the Pearson correlations, we can use this following formula. Rxy is equal to sigma xy per root of sigma x squared times sigma y squared. Next is SPSS. SPSS, or Statistical Package for Social Science, is an applications program that has high statistic analysis capabilities and a data management system in a graphic environment with a very simple operation method that is easy to understand. This application is one of the software applications that is widely used along with the development of science and technology, where many institutions want research in various fields. SPSS is also a powerful statistic software program with a graphic interface designed for each of use. All commands and options can be accessed using pull-down menus at the top of the main SPSS windows. The next is sample case. An HR manager of so-so company wants to examine the relationships between motivations, it is the X variables, and work performance, or Y variables, of 53 employees. The employees' data are as follows. So, my friends, you guys can see all the 53 cases in the screen. The motivation is X variable and work performance is Y variables. The next is procedure. We would like to operate it directly on SPSS applications. So this is the SPSS applications. First of all, I have written all the data needed in the SPSS. So on this opportunity, we would like directly to see how to do Pearson correlations using SPSS applications. The first is we should click the Analyze menu. After we click the Analyze menu, we go to the Correlate submenu. You guys can see it, there are 4 submenus in the Correlate. Because we would like to conduct a person's correlations, we should choose the bivariate. After that, it will be like this. The next steps is we should move all these variables into the variable box. We just click the arrow marks, and then for the correlation coefficients, we select percents. For the text of significance, we use two-tailed, and we mark the flag significance correlations box. And the next is we choose the options box. We just have to click it. And this, we should use the missing values. We choose exclude cases per risk. And then for the statistic, we just ignore it. Then click continue and then click OK. So the output of this Pearson correlations appear. After we conduct the calculation using SPSS, when we done doing it, then the output will appear. If you guys do the Pearson correlations correctly, the output will be like that. There are two variables, motivations and work performance, and then there will be Pearson correlations. It is 0.563 and the 6-to tail, and the n is the cases total is 53. And also it is the same with the work performance. For the Pearson correlations, the result is 0.463 and the 6-to tail is 000 and the n is 53. And now we would like to discuss about the manual calculations. The first is the table of data. You guys can see it because there are 53 cases in this Pearson correlation analysis. So there are 53 tables of data, and the sum of X variables is 1,974, and the amount of the work performance variables is 1,368. And the next is hypothesis. The first hypothesis is HO. There is a significant relationship between variable X or variable motivations and variable Y or work performance. And the second is H1. There is no significant relationship between variable X or motivations and Y or work performance. And the next is finding the correlations coefficients. In these correlation coefficients, it will be easier if we use this table, these following tables. There is the X variables, Y variables. X is equals to Xi minus X. Y is equals to Yi minus X. And this is the X square, the Y square, and the XY. So after redoing the manual calculations of all these 53 cases, we got the results of the correlation coefficients tables as you guys can see it on the screen. And the next, it's still defining correlation coefficients. If the sum of X is 1,974, then the X bars is we can see it. We can calculate the result using the sigma X per n. So we got the result is 37.2. And the next is if the sum of Y is 1,368, then the Y bar is equals to 25.8. So the next steps in the manual calculations is the calculating correlations between var X and var Y. So this is the following formula that we can see. We have discussed it in the theoretical reviews chapters. So XY is 416.448 divided to the roots of 949.92 times 850.12. So we got the RXY result is 0.46345846676. So based on the error calculation above, we can see it and we can see that the error calculation result is the same with R in the SPSS application output. So we can conclude that that our manual calculations is right. And the next is calculating degree of freedom. So the formula of df is n minus 2. I have explained that the number of cases is 53. So 53 minus 2 is 51. The alpha is 0.05. And so the df is error table is 0.266. And the next is the decision rules. If error calculations is less than error table, so HO is rejected. If error calculations is more than error table, so HO is accepted. If sig is less than 0.05, so the variable X and Y have significant correlations. If sig is more than 0.05, so the variable X and variable Y don't have significant correlations. After the decision rules, we get the conclusions is, after doing manual calculations, we can see that our calculations is more than error table. We clearly know that 0.563 is more than 0.266, which means HO is accepted and H1 is rejected. So we can conclude that there is a significant relationship between motivations or X and work performance or Y of 53 employees. We also can see from the output that the value of R is positive, and it is mean that the variable X and variable Y have a positive correlations. And we can see that sig is less than 0.05, so we can conclude that variable X and Y have significant correlations. And the next is interpretations of output. So the Pearson correlation coefficients is represented by the Greek letter rho for the populations parameter and R for a sample statistic. This correlations coefficient is a single number that measures both the strength and directions of the linear relationships between two continuous variables. First is strength. The greater the absolute values of the correlation coefficients, the stronger the relationships. And the next for the directions, the sign of the correlation coefficients represent the directions of the relationships. Positive coefficients indicate that when the values of one variable increases, then the values of the other variables also tends to increase. Positive relationships produce an upward slope on a scatter plot. Negative coefficients represent cases when the values of one variable increases, the values of the other variables tends to decrease. Negative relationships produce a downward slopes. So, if we would like to determine whether the correlations between variables is significant or not, we have to compare the p-value to the significance levels. Usually, the significant levels of 0.05 works well. An alpha of 0.05 indicates that the risk of concluding that a correlation exists when actually there is no correlation exists is 5%. The v-value tells you whether the correlation coefficient is significantly different from 0. First is p-value is less than equals to alpha, the correlation is statistically significant. And if the p-value more than alpha, the correlation is not statistically significant. You guys can see it our SPSS output that we can clearly see that the variables named into two rows. In the first is work performance. I'm sorry, there is a mistake. It is true. The first is motivations, and the second row is work performance. We also see that the two variables named into columns. And next, we will see 4 boxes on the right-hand side. These boxes will all contain numbers that represent the variable crossings. For example, the top box on the right represents the crossing between the motivation variables and the work performance variables. The bottom box on the left also happens to represent this crossing. These are the 2 boxes that we are interested in. They will have the same information, so we really only need to read from one. In these boxes, we will see that a value of Pearson's seek-to-tail values and a number and values. Based on the output above, we can see that the Pearson correlation result is 0.463. We clearly know that the SPSS output have the same result with the manual calculation, and we also can see that the n value is 53. It means there are 53 cases used in this paper or in this research. Based on the output above, we can see that the Pearson error result is positive. We all know that 0.563 is more than 0. It's a positive value. This means that as one variable increases in the value, the second variables also increase in value. Similarly, as one variable decreases in value, the second variables also decreases in value. This is called a positive correlations. In our example, our Pearson R value of 0.5346 was positive. We all know that this value is positive because SPSS did not put a negative sign in front of it. So, positive is the default. Since our example Pearson's R is positive, we can conclude that when the amount of motivations increases, then the participants of the work performance is also increases. So the closing chapter will be explained by my partner Dea.
Now, we will explain to you about the closing chapter. Based on our SPSS output result and our manual calculation results, we have conclusions from our problem formulations before. There is 4 conclusions. First, Pearson's correlation coefficient is the test statistic that measures the statistical relationship or association between 2 continuous variables. It is known as the best method of measuring the association between variables of interest because it is based on the method of covariance. It gives information about the magnitude of the associations or correlation as well as the directions of the relationship. Second, To run a bivariate correlation in SPSS, we can click Analyze, then we click Correlate, then we click Bivariate. The bivariate correlations window open, where you will specify the variables to be used in the analysis. All of the variables in your dataset appear in the list on the left side. After that, move motivations and work performance to variable box. For correlate coefficient, select Pearson. For text of significance column, select to tailor. For text significant correlate options, select the mark. Click option box, and for the statistic menu, just ignore it. And for missing values menu, select exclude cases pairwise. And next, we can click continue and then click OK. The third conclusion is we can see the formula below to calculate Pearson correlation manually. Rxy is equal to sigma xy divided by roots of sigma x squared times sigma y squared. The fourth conclusion is the result of Pearson correlation in this paper is 0.46345846676. These calculations have the same result with SPSS output. We also get that R calculations is more than R table, or 0.46345846676 is more than 0.266, which means HO is accepted and H1 is rejected. So there is a significant relationship between motivations and work performance. Suggestion: we hope that this project task can be references and guidance for people such as students, teachers, lecturers, or anyone who want to find Pearson correlation by using SPSS. We hope that this project task can be better in the future. We think that is all about our presentations of our project task, analyzing Pearson correlation using SPSS applications. Please forgive us if there is a mistake in our explanations and pronunciations. And thank you.